In section 37, we will graph piecewise functions. The use of the calculator is not allowed on this section. When we graph the piecewise functions, we're going to start by graphing the endpoints of each piece. From there, if it's included, we're going to use a filled in circle. If it's excluded, it's going to be an open circle. Step 2 is we're going to connect the endpoints if it's linear. If it's not linear, which is going to be rare for us to see, then we're going to have to look at it from a different perspective. The third thing listed says that in this course, piecewise functions will be graphed from -10 to 10, including -10 and 10. So we start with this first graph here. Now, one thing I like to do is take at -3, I want to kind of remember that at -3 right here, this is where my break in the graph is going to occur. So on this side of -3, I will be graphing x plus 5. On the right side of -3, I'm going to be graphing -x plus 2. You might even consider, and this is what I'll do when I'm showing this in class, x plus 5, writing that up here, and writing -x plus 2 right here. Now, if we're supposed to be plugging in the endpoints, when we're working on this side of the function, we're going to be plugging the endpoints in at -10 and also at -3, because again, that's where that break in the graph occurs. So if I plug in a -10 for x plus 5, -10 plus 5 is going to give me -5. That means that I'm going to be plotting a point at -5 here. Since that's included, because we said that it had a bracket there, that is then going to be a closed circle. Then when I'm plugging in -3, f of -3, that's going to be -3 plus 5, which is going to give us 2. That one is not included because it does not have an equal sign. So now I'm going to go to -3, which is here, and I'm going to go up to +2, which is here, and I'm going to plot that. But it's again going to be an open circle. Now I can connect that with a straight line because this is linear. Now when I switch to this one, again, I'm going to start with the endpoint. I'm going to go left to right. So when I'm plugging in -3, f of -3, it's -3, which makes this a +3, and 3 plus 2 is going to be 5. And this one is included, which means it's going to be closed. So I've got to go back to -3, which is here, and I go up to +5, which is here, and again, that's a closed circle. From there, the end of that region is going to be at +10. So I'm going to go ahead and plug in f of 10 now. So again, I'm plugging it into this function part right here. So it's -10 plus 2, which is going to give us -8. And because we said at the beginning of this lesson that it's going to have a bracket there, we would include this, meaning that it's going to be a filled in circle. So we go up to 10, we go down to -8, and we're going to plot. Now I can connect those 2 points with a straight line, and we should be using a straight edge for that, and that is going to be my graph. For number 2, again, we have 2 pieces here. So when I'm looking at my first piece here, that one's going to go from -10 up to -6. So I would consider putting like a little dotted line right here, very light, because it's not actually part of the graph. And above that, writing in 1/2 x plus 6. Now our other one is going to start at -4, and it's going to go all the way up to 10. And so again, I might draw this like dotted line very lightly at -4, and above that region, that whole entire region, write in -x plus 4. Now when I go to plug things in here, at -10, I'd be plugging that into this function here. So half of -10 is going to give me -5. -5 plus 6 is going to be 1. That is included, so I'm going to go ahead and make a closed circle at that point at -10 comma 1. Now I'm going to plug in -6. When I plug -6 in here, I get half of -6 is -3. -3 plus 6 is going to give me +3. Which is going to go here. It's filled in because, again, it's included since that's an equal sign, and I can connect those points. Next, I'm going to start at -4. When I plug that in, I've got -4, which is +4. 4 plus 4 is going to be 8, and once again, it's an equal sign, so it's going to be included, therefore, in a closed circle. So that's going to be here. Then I'm going to plug in +10. So if I do g of 10, Again, I'm plugging it into this part of the function. So this is negative 10 plus 4, which is negative 6. And once again, that's going to be included. So I can connect those points. For this next one, we can see that we have 3 different pieces. So I have one piece that's going to be to the left of negative 2. So I could put a little dotted line right here, and above that write in negative 1/2 x plus 3. My next region is going to go from negative 2 up to positive 2. So in between those 2 points, I could put an x above that region. Then from 2 up until 10, because it's just going up until the end of this graph, I could write out 1/2 x plus 1. So now as I start plugging things in, this top function is going to go from negative 10 up to negative 2. So when I plug in h of negative 10, negative 1/2 times negative 10, that's going to give me positive 5. 5 plus 3 is going to be 8, and that's going to be included. So I can make a closed circle at negative 10 comma 8. Now for my next point, I'm plugging in this negative 2. Well, negative 1/2 times negative 2 is going to give me, I've got negatives canceling, half of 2 is 1, so 1 plus 3, that's going to give us 4. And again, at negative 2 comma 4, it's going to be a closed circle. Now I can connect those. My next region starts with negative 2 and ends with positive 2. When I plug that negative 2 in for x, it's just going to give me negative 2. It's not included, again, because it doesn't have an equal sign there. So I go to negative 2 and down to negative 2 and make that an open circle. Next, if I plug in where x is less than 2, again, that's just going to give me 2 when I plug it in for this function. So if I go to 2 comma 2, that would not be included because it doesn't have an equal sign. Now I can connect those 2 points. And then my last region is going to start with positive 2. So I plug that in for x here. Half of 2 is 1. So I've got 1 plus 1, which is going to be 2. So 2 comma 2 is actually already plotted. So I'm just going to put another open circle on top of that. Now, if one of those in that same exact position had an equal sign in it, that would be filled in. So the filled in circle would always carry more weight than an open circle. So if you have a filled in circle in a position, you have to fill it in. If you have 2 open circles, you can just leave it open. And then finally, I'm going to plug in 10. So half of 10 is 5, and 5 plus 1 is 6, and that is going to be included. And we're going to assume that these endpoints are always filled in unless otherwise stated in these regions. So I can go ahead and plot that, and now I'm going to connect these 2 endpoints. For number 4, again, if I wanted to, I could plot a line at negative 5 and write 2x plus 12 up here. Then I would start from negative 3 up to 4, make 2 real light lines, and between that I would be writing out 7. And then from positive 4 up until positive 10, I'd be writing in negative 2x plus 11. So my first region, I'm starting at negative 10 and plugging it in. 2 times negative 10 is going to give me negative 20. Negative 20 plus 12 is negative 8. It's going to be included. Again, we're making the assumption that this is a closed circle unless it's stated otherwise up here. So I can plot that point here. Then I'll plug in negative 5. So 2 times negative 5 is going to give me negative 10. Negative 10 plus 12 is going to give me 2. That's going to be included because that has the equal sign. I can go ahead and plot that and connect those 2 points. I move on to the next region. The next region is going to start at negative 3. If I try to plug negative 3 in for 7, it's just going to be 7. And that is not going to be included because it doesn't have the equal sign in it. So we're going to leave that as an open circle. So at negative 3 comma 7, it's open. Then I'm going to look at k of 4. And again, when I plug that in, it's just going to give me 7. And once again, because it doesn't have the equal sign, it is not included. That means that it's going to be open. So I can connect those 2 points. And when we see that this is a constant like that, it didn't have a variable in it at all, it should be coming up as a horizontal line in our graph. Then finally at 4, if I plug 4 in here, that's going to end up giving me 3. Negative 2 times 4 is negative 8. Negative 8 plus 11 is 3. It's included because it's got that equal sign in it. So I'm going to go ahead and fill that circle in. Then finally, if I'm looking at positive 10 here, Negative 2 times 10 is negative 20. Negative 20 plus 11 is negative 9. And at negative 9, it's going to be included. So I can go ahead and plot that and connect those lines, and that'll be my graph for number 4. Try number 5. And on number 5, we've got many different interruptions. So again, you might consider, and this is how I'm going to teach this in class, at negative 6, I'm going to make a dotted line very lightly. I'm also going to make another one at negative 4, at positive 2, at positive 4, at positive 7. And above each of those different regions that are created, I'm going to write down each of these different functions. So 1/2 x plus 4 would go up here, and that's going to go from negative 10 up until negative 6. So now I'll plug those values in. When I plug in negative 10, half of negative 10 is negative 5. Negative 5 plus 4 is going to give us negative 1. That means I need to plot a point at negative 10, negative 1. It's included because, again, we're making that assumption unless we actually see negative 10 in the graph with a greater than symbol, not the equal sign. Next, when I plug in negative 6, half of negative 6 is negative 3. Negative 3 plus 4 is going to give me 1. That's going to be included because it has the equal sign in it. So now I can plot a point at negative 6, 1, and I can connect that piece. I move on to my next piece. This piece starts at negative 4. When I plug negative 4 in here, negative 2 times negative 4 is positive 8. Again, it doesn't have an equal sign, so it's not included, which means it's an open circle. So at negative 4, 8, I make an open circle. Next, I look at 2. When I plug 2 in here, I'm going to get negative 4. Negative 2 times 2 being negative 4. This one has the equal sign, so this one's going to be included. So I can plot a point at 2, negative 4. Now I can connect that piece. My next piece is going to start at positive 4. When I try to plug 4 into this function, again, there's no variable to plug it into, so it's automatically just going to be 5. So I can plot a point at 4, 5. So I go over to 4, up to 5. And this point is going to be included because it has the equal sign. Then if I plug in 7, I'm also going to get 5. This one's not included because it doesn't have the equal sign. And I can connect those two. Then finally, when I'm looking at 7 to 10, at 7, when I plug that in, it automatically is just going to give me 6. And that's going to be included because it does have the equal sign. So I'm going to go to 7, 6, and that is going to give me a filled in circle. From there, I'm going to end this at 10. So when I plug 10 in, once again, I just get 6. It's included. Plot that, connect it, and that would be the result. Try number 6. And again, you may consider the way that I'm explaining it, where we put a little dotted line at negative 4, separating out this first region that goes from negative 10 to negative 4. Then I'm going to have another dotted line at positive 2, showing me that from negative 4 up until 2, I'm going to have a region that I'll graph. Then from 2 to 6, I'll have another region. And then finally from 6 up until 10, I'll have my final region. So when I'm working with my first region, that goes from negative 10 up until negative 4. When I plug in negative 10 plus 8 gives me negative 2. Again, that's included. So I plot negative 10, negative 2, and it's filled in. Then I can plug in negative 4. Negative 4 plus 8 is going to give us positive 4. That's going to be included. So at negative 4, 4, I made a filled in circle, and then I can connect those 2 points. At negative 4, I plug that in here. Negative 2 times negative 4 is positive 8. 8 minus 4 is going to give us 4. So I go to negative 4 up to 4, and it would be an open circle, but I already have a closed circle in that exact same position. So I can't get rid of that closed circle. I'm just going to leave it looking like a closed circle. From there, I'd be plugging in this 2. When I plug in 2 here, I'm going to end up getting negative 2 times 2, which is negative 4. Negative 4 minus 4 is negative 8. So again, I'm plotting 2, negative 8, which is down here. And it is going to be open because, again, I didn't have the equal sign here. My next region starts at positive 2. When I plug that in here, I'm going to get negative 8. Once again, that's going to be an open circle because I don't have an equal sign. So I go to 2, negative 8. It already has an open circle there, and I just put another one on top or just leave it alone. It already has an open circle there, so I can just leave that alone. Then when I'm looking at 6, plugging that in is going to give me -4. So I make a point at 6 comma -4. Again, it's open because it doesn't have the equal sign and I can connect. Then finally, when I'm plugging in 6 to this function right here, it's just going to remain -4. That means that where I already had an open circle, now I have a closed circle on top of that. So it's just going to appear to be closed. Then when I'm plugging in 10, that's just going to give me -4 again. It's going to be included. And again, I connect these 2 points, which does give me that horizontal line. And I should get a horizontal line every time it's a constant function. So now please complete the exit slip for section 37, and your homework is in practice set 37.